Okay.
All right, so our next speaker is Arcot Rajasekar of the University of North Carolina at Chapel Hill. And he's going to be talking about, can blockchain technology play a role in iRODS? Take it away, Raja.
Okay, thank you very much. So my talk is about, can we use blockchain technology in iRODS, and is it going to be effective or not? I'm trying to change my slide. Ah, oh. Okay, the outline of my talk is that I will try to introduce a little bit about blockchain technology. I suspect most of you know about it, but I thought it's a good idea to outline a brief intro to BCT, and then I will talk a little bit about how iRODS is related to the blockchain technology. And finally, I will also talk about what are some of the ideas which are in the BCT which can be applied to iRODS, and then open up for questions. Okay? So, what is blockchain technology? At its core, it is a recording system. It's a transaction recording system with no centralized control. That's how you can view it. And it is a storage for digital assets. In this particular case, they are storing what are called transactions of how people do things. So, in a sense, it is similar to iRODS, where we store things, digital assets, but happens to be data sets, happens to be documents, and so on and so forth. Whereas there they are very simple types of transactions which are being recorded. So there are a lot of similarities between the blockchain technology tries to do and what iRODS is trying to do. It is a digital ledger in a sense that we are trying to do um, the type of functionalities are similar to what iRODS does, but some of the important things which are provided by the blockchain technology is that its immutability. So that if somebody puts in a transaction, which can be something to do with transfer of money, or it can be anything else also. There is in the BCT itself, it doesn't look at what type of transaction is being done, but it is something which is being recorded in there. So it can be a land a sale recording or something like that. It doesn't need to be anything to do with bitcoins or something like that. And one of the good things about that, anybody can see the data but cannot corrupt it. So it's like an open ledger in that particular sense. And one of the important things is that it is decentralized governance. And there is no central authority which is needed to provide some sort of way of giving integrity for that particular one, but it provides what is called a consensus based integrity check, and highly secure. It has got really good provenance using time stamping, and uses digital signatures for trying to figure out who is doing what, in a sense. So that's a really good way of doing it, and similar to what we are doing in our own way of providing some sort of a digital user, what you can call in iRODS as a virtual user is being provided to do that. And behind the virtual user, you can be anybody. It doesn't matter at all. Anonymity, if needed, is provided, and they also have triggers type of thing like what we have in iRODS, where you can have programmable transactions. So the blockchain can do things which can happen at a particular time or event, depending upon what you're trying to do. Okay, let me see what is. So the applications of BCT. And one of the most what do you call known, very well known application is the Bitcoin technology. So Bitcoins or any other cryptocurrencies are very good examples of applications of BCT. Distributed ledger for holding and verifying transactions of movement of money from one person to another person. That's what is mostly it is being used for. You can also, in the Bitcoin, the way it is being done, it is not just used for transactions, but also when somebody creates a new Bitcoin, a unique Bitcoin, and you can create only a known number of Bitcoins in a particular ledger type of setting, and you mine for that. I'm not going to go into details of that particular one. There are a lot of places where you can find that type of information, But one of the important things which you can say about these is that these miners have a lot of computing capabilities so that they can verify if a transaction is good or not, and they can reach a consensus based on that. They use a lot of crypto technology to do these type of verification as well as for mining, which makes it very hard and highly secure when these transactions are being recorded. When a new Bitcoin is created or a new block is created and chained in a BCT technology. Remember, Bitcoin is an application of BCT. It's by itself is not a BCT. So the broadcast of transactions across a P2P network is very similar to what we do in iRODS also. Our iRODS also has the resources, and the resources can talk to each other anytime they want and things like that. There is no way of trying to do only a point to, like a centralized, always go through the centralized thing. Even though the ICAT is in some sense like a centralized authority, a movement of data can be done between one resource to another resource without having to go through the ICAT system. One of the other important things about these cryptographic algorithms is used for doing validation. And multiple people will try to be able to use that validation to say, yes, a new Bitcoin is created, or yes, this transaction is a valid transaction and we can authorize it. In some sense, that type of distributed consensus is basically used instead of in a banking system. When you move from money from one account to another account, a centralized authority like the Bank of America or the Federal Bank or something like that is actually doing that type of authoritative action to say that this money has been moved from point A to point B. Here, multiple people have to draw a consensus and say, yes, this is a valid one, this person really has the money, and we can move the money to this particular person and stuff like that. So in a sense, multiple verifiers, multiple consensus is really helpful, and these miners get rewarded for doing that. That is a little bit of a problem in a system like iRODS, but let us see how we can still use the BCT technology type of thing for iRODS. And these, once a transaction is verified in the Bitcoin transaction has been verified, they are basically added to a ledger. That this transaction of money is moved from A to B is added by creating a new block, and this block is hashed together, encrypted, time-stamped, and chained with the older blocks. Basically, when you chain a new block to the older block, you basically look at the hash of the older block and add it to that and make it as a new chain in there, new block in the chain, and that's why it is called the blockchain technology. In a sense, the name comes from that particular one. And it makes it immutable because every block has in a sense, an inherent memory of the previous block because of this type of hash coding which is being done. I also want to talk a little bit about the wallet type of thing, which is basically the client side of the Bitcoins or any other cryptocurrency. I'm using the word Bitcoin because most people are familiar with it. You can talk about any other cryptocurrency is very similar in operation to that type of thing. So the user who wants to own or transfer or mine new Bitcoins, they use the public key, private key type of combination, and they get validated. So that gives you anonymity, but the point is that you can get stolen, and you store this private information in a wallet, which can be on your laptop or desktop or your iPhone or any digital device. You can have it and use digital signature to validate that particular one. So you can see how the blockchain technology has a really good application in cryptocurrencies. Going forward, there are other applications which are coming up using the blockchain technology itself. One of them is sharing of documents, medical documents, financial documents, and so on. So basically, like I said, the BCT technology itself provides you with a lot of immutability and validation and security and so on, which are really useful for transferring data, medical data, financial data, and so on. So if a doctor wants to take a patient's clinical information and want to give it to somebody else, that is a transaction in a sense. And you want to make sure only the people who are making the transactions are only looking at it and are allowed to do that and so on. And you can use the blockchain technology to do that. The other one is non-fungible tokens, where you can have some unique digital asset which you can sell it, like an artwork or things like that, and you can sell that, and that is becoming a rage now in a sense. And the BCT is basically used as a way of showing that ledger where somebody owns it and somebody can use it and somebody has sold it to them and so on. Logistics monitoring and supply chain is another really important type of BCT application where because again in a supply chain, the main things which are being moved are the real items, maybe the part of a car or a chip being transferred from one factory to another factory and so on. That is where the supply chain comes in. But in parallel to this physical type of movement, you also have a digital movement also happens at the same time, and keeping track of the digital movement of that information can be done in the blockchain technology. It has nothing to do with bitcoins and things like that, and it's a very easy way of doing it. And once a move has happened, you can record it. Anybody can look at it, so they can make sure that everything is moving right well. So in parallel to your physical supply chain, you can have this the same type of logistics being happening in the digital realm, and you keep monitoring that and making sure that everything is fine. And somebody says, hey, I sent you something, did you receive it or not? You can actually go and look at that in this ledger to try to do that. Similar to that, like real estate transactions in a sense, who sold what house to whom, who really owns it, which particular part of it, and so on and so forth, can also be put in as a transaction in a blockchain technology. Right now, if you want to do that, you may need to go to the county or the state records, and then go and ask them to look at the records of who really owns it, when did they buy it, what did they do it, and so many things happen to a real estate in a sense. What can be done with it? Are there other type of encumbrances in there, and so on and so forth. So all those things can get recorded in a blockchain type of setting, rather than trying to do that in a type of thing like paper based or even document based, PDF based type of thing, which is right now being done in most of the counties and most of the cities in US, and actually in abroad at all, in everywhere. Voting is another one. Again, a big things where security and immutability, mostly importantly, immutability is a really important thing. Who is that particular vote being done? Has it been not been changed, and so on and so forth, is really important. Again, blockchain technology provides you with a really good way of doing it. Cryptocurrency, like I said, is always there, but there are other types of things which are in there. Security in real-time IoT operation is now being an important part of things. Why is that? Because when you have a lot of sensors operating, you need to make sure that you are getting data from the right sensors and nobody is spoofing it, type of thing. And you are to make sure the timestamp is correct and you are getting the exact correct records, and so on and so forth. And if you want to do that, blockchain technology provides you with one way of making sure the security and authority is being done, and immutability is also being done there. And also in a lot of government operations, people are looking at how they can replace the normal databases in a sense, and apply the blockchain technology as a database technology. You can store royalties and patents and so on and so forth. Again, immutability is the most important part of it, and you can deal with those type of applications using the blockchain technology. Okay. So I just want to give a very brief view of the internals of the blockchain technology. It basically it consists of nodes, very similar to what we do in iRODS. You got a lot of resources. Here you got a lot of nodes, and these nodes are basically, they maintain copies of transactions or hash values of transactions. Transactions can be pretty large, so you can convert that into a fixed 32-bit number, which is unique type of thing, and use that as a hash value for a transaction type of thing. In a sense, there can be a lot of nodes. That means more the nodes are there which are able to keep these transactions and verify transactions. They're not what you call passive databases. They are actually active in the sense that they can take verification of is this really correct or not, and so on and so forth. So these nodes play a major role in blockchain technology. Underneath the nodes, you basically have a database, that is the ledger itself, which contains three types of ledger. I'm not going to go into much into details. The public ledger is probably the most prominent one, where anybody can look at what are all the transactions which has happened in there. And these public ledgers can be distributed. There can be private ledger also. They can be distributed and decentralized. So there are slightly simple differences between the type of things we can do in these distributed or decentralized, where in some sense how many people are doing it. It can be distributed but not be decentralized, or it can be decentralized and not distributed, and so on. So you have some nuances in how you can create your ledger to be used by the system. And they also have a unique, because we are using crypto technology here, you want to find out the unique keys which can be there, and they call it the nonce, or the number only used once type of thing. It's a random number, a 32-bit number being generated and hashed to an encrypted block in a blockchain. Okay, that is where you get the immutability type of thing which comes in along with the hash. The data is mapped to a fixed size using hashing, and this hash value of one transaction becomes the part of this input to the next transaction when you create the next hash value for that. So you can see that there is some sort of history built into it. It's almost like genetics. So when two what do you call it, cells meet and then transform, you can easily see that they get parts of one gene from here and a parts of another gene from here, the two parents genes, to form the child gene. You can say something similar is happening in this particular case, that the hash value of the previous transaction is also part of the new transactions comes in there. That is another place where the immutability of the blockchain technology is a very powerful feature, not available in multiple other types of things which are being done. Databases don't have it at all. Again, I talked about triggers where you can have some similar event-based or time-based type of things can happen. Proof of work and proof of stake are basically how you get paid for it or not paid for it in there, and wallets is like I talked about, provides you with keeping track of your authenticity and if you have some balance in your bitcoins and so on. So let's go forward. Time is running out, so I don't want to take into too much of time.
Raja, yeah. We're actually at the time limit.
Ooh,
and so
I thought I got. Okay, let me give me 2 minutes. I didn't get a 3-minute window. Okay.
All right.
Okay, let me go forward. Really look at what can iRODS learn from BCT. So we can make use of the distributed ledger concept, the hash chaining concept, the distributed consensus concept, and the proof of stake concept, and the verification concepts. How can we use that? We can give more features and functionalities to iRODS for keeping the medical records as well as financial records. You can make some unique, you can borrow some of these things and uniquely provide safety and security for some of the things beyond what iRODS provides. And similarly, integrity and provenance for genomics and other published data. And we can also have a private data distribution technology built into iRODS and do something like a paywall type of thing by adding the BCT into it. We can redefine the BCT transactions into iRODS and use the data asset transaction or metadata asset transaction. And we can use the concept of wallets instead of using iRODS users. And almost one more thing. We can also, the ICAT functionalities can be changed a lot if we adopt the distributed ledger concept in the BCT. It can increase our speed, and we can also have a private ICAT and a public ICAT type of thing. Those are type of consensus which we can, different type of things we can do, which we never even thought about if we can do it in iRODS. We can apply the hash chain concept to increase security, integrity, and safety of it. And the single ICAT bottleneck can be removed by doing what is called distributed consensus for writes. Writes is now a bottleneck in iRODS, and by doing this type of distributed lazy synchronization, we might be able to do. And we can introduce the concept of incentivization into iRODS, and maybe not all resources are really equal. Some resources have a little bit more power, and some other resources can get something back from there, type of thing. So some of the concepts in there can come back. So I think I will stop here and hope to answer some of the questions you have. Thank you.
All right. Thanks, Raja.